Everyone always asks me what's the number one thing you have to get right in astrophotography, and I always say the same thing: polar alignment. So in today's episode, I'm going to break it down. Welcome back, my beardos. Today we're going to be talking about coordinate systems and polar alignment and how they affect astrophotography. And you really have to know why this is important and understand the fundamentals, because when you do understand the fundamentals, everything in the hobby gets easier. So let's get going and let's start with coordinate systems. So the first type of coordinate system is the alt-az coordinate system. Sometimes it's known as the horizontal coordinate system. And it's a very simple coordinate system. It's basically based on two points, the altitude and the azimuth. The azimuth is the horizontal position, and the altitude is the vertical position. That's the way that you can think about it. It has some advantages in that it's a super simple way to look at the sky, and it also has its disadvantages. This coordinate system is actually great for things like observing, if you're going to be observing an object, or if you're doing like planetary photography, because it is really easy to align. Now, it also has some really big disadvantages, and the first one is it doesn't have like a central reference point that it works off of. It basically works off of your location. So depending on where you are, the altitude and the azimuth of a particular object will be different in the sky, and depending on the time, it will also be different in the sky. And so as you track on a mount that uses this coordinate system, the mount has to track in like two positions, in both the altitude and the azimuth for most locations, unless you're like right at the equator. All right, the other type of coordinate system is called the equatorial coordinate system. And imagine that we wanted a coordinate that I could share with you or share with other scientists, that scientists could share with each other, that gave you the exact precise location of an object in the night sky, no matter where you were on the globe, and no matter what time of year it was. And this is the equatorial coordinate system. That's kind of the basic goal of the equatorial coordinate system. So if you want to know where a particular item is in the sky, you can take the two coordinates that come with the coordinate system, the right ascension and the declination, and you can use those to identify where an object is in the sky. So the equatorial coordinate system is very fundamental to astrophotography, and the reason why that is it tracks objects through the night sky naturally, the way that they're moving through the night sky. It'll make a lot more sense later when we talk about the different types of mounts that there are out there. So let's imagine the sky is a globe, and it surrounds the Earth. And we're just going to do the same thing that we do on the Earth to draw a position. We're going to draw latitude and longitude lines across that globe. And based on that, those two coordinates should tell us where an object is in the sky any time of the year. There's only one additional component that you really need to know, and that's the time. That depends on the time of year and the time of day. But I can share a coordinate with you that has these two components, the latitude and longitude, and as long as you know the time of day, then you'll know where this object is in the sky. It really is that simple. So the latitude coordinate in the equatorial coordinate system is called the declination, and the longitude is called the right ascension. So the declination is written out in degrees. So right ascension, because it's time-based, it can go from 0 to 24 hours. And so just think of it that way, where 0 is at the prime meridian, and 24 hours is all the way around, right? So that's the way that you really want to think about the equatorial coordinate system. So when you get any object, it will have a declination component and it will have a right ascension component. Now keep in mind that the right ascension is super important in the equatorial coordinate system. The position of the right ascension in the sky will change over the night. Not the coordinate. The coordinate will be the same, but its position in the sky will be different throughout the night. And so when you're tracking in an equatorial coordinate system, you track only in one direction, only in the right ascension component, and that is like really super important. Now, there's one other piece of information that you actually need. You need the point of reference. If you remember when we were talking about the alt-as coordinate system, the alt-as coordinate system is based on your location. And so you have to know your location, you have to triangulate your position, and then based on that, you can figure out kind of where an object is in the sky. With the equatorial coordinate system, there is a point of reference that you have to use, and it depends on which hemisphere that you're in. And the point of reference in the northern hemisphere is called the North Celestial Pole. The North Celestial Pole is the point at which everything else revolves around. So if you're in the southern hemisphere, it's the same concept, but you're going to align to the South Celestial Pole. So what kind of mounts are out there? Well, for the most part, there's actually two types of mounts. There's the alt-as mounts, and there's the equatorial mounts. Sound familiar? Both of these mounts follow those different coordinate systems. And so the alt-as mounts will track things in the night sky using the altitude and the azimuth. And essentially you'll do a star alignment, you'll put in your location, you'll put in the time, and based on those components, it will track the objects in the night sky. Now, why are alt-as mounts not typically used for deep sky astrophotography? And the reason why is because of the way that they track. So they're going to track things in both of those directions, so they'll go up and then to the side, up and to the side. But you have to remember that as the Earth rotates, because it's a globe, and as it rotates, those objects in the night sky, both the altitude and the azimuth will change. So if you're tracking in both of those directions, for the most part, unless you're in, I believe when you're on the equator, you don't have to worry about that. But everywhere else on Earth you do. What ends up happening is the object that you're imaging will rotate in the image, and you end up having to crop a lot of the image out. Just tracking in general, getting things aligned, when you do your stacking and alignment, things just don't add up. They don't look right. So unless you're taking a picture of like a really bright object, so if you're doing like a planet, for example, or you're doing like something that's super bright, you don't have to take a really long exposure for. Those are typically okay for alt-as mounts, but for anything else, which is almost everything else, it's not a good option. The image that you see behind me, that image actually took me 25 hours of exposure time. I would have had to crop out so much stuff out of that image, and it wouldn't have looked right. It wouldn't have come out right. So it's not ideal for astrophotography, at least not deep sky astrophotography. So the other type of mount that's out there is the equatorial mount. Now, all sorts of companies are trying different things and billing it as something new, but at the end of the day, it's the same thing. Before we go into that, let's just talk about like what an equatorial mount actually is. An equatorial mount is very simple. It is a alt-as mount that's sitting on top of another alt-as mount. And what you do is you actually will align the bottom alt-as mount to the celestial pole. And if you're in the northern hemisphere, it's actually like fairly easy because you have a great star, the North Star Polaris, that you can use to help figure out where that point in the sky is. And then once that's pointed in the sky, then you can track in a single direction in right ascension. So over the night you'll track in one direction throughout the night. And that's actually great because all you have to do is compensate for the rotation of the Earth. That's essentially what you're doing. So there's a whole bunch of different companies that are billing things as something different. For example, there's Ioptron, who will they have their center balanced equatorial mounts, which I hear great things about. I use German equatorial mounts. So far, all of except one are made by Celestron. There's a company out in Italy called Avalon. They make like a fork mounted, a single fork arm equatorial mount. And you can also, if you have an alt-az mount, like if you have a really good one, you can get a wedge for it. And when you get a wedge for it, the wedge basically acts as the second alt-az mount that sits underneath it. And you can actually convert it to use the equatorial coordinate system. So actually a lot of the Celestron mounts do that, and I believe even the Meade mounts will do that as well. So those are the two kinds of mounts that you can get. I would say to anybody, like a lot of people go and look at these expensive telescopes, and I did that too when I first started, but I'll tell you, where you should be investing your money, if you want to get into this hobby, you should actually invest your money into the mount, not into the telescope, not into the cameras or anything like that first. The mount is the most critical thing because the mount is what's going to allow you to take really long exposures. And the quality of the mount really matters. I mean, the slightest bit of difference between the worm gears inside this mount can make the difference between being able to take a 1 minute exposure and a 5 minute exposure. And being able to take a 5 minute exposure, there's some targets that you absolutely need that really long exposure time to be able to get them. I'm taking an image right now where I'm taking 5 minute exposures, and that's not even enough. So it's super critical. But the biggest advantage of these equatorial mounts is the fact that they only have to track in one direction, and they only have to compensate for the rotation of the Earth. Just keep that in mind. All right, let's talk polar alignment. Are you ready for this? Let me tell you exactly what polar alignment is. It's basically aligning to the celestial pole. You remember when we talked about that you had to have a frame of reference or a point of reference that you are pointing your telescope towards? That's basically what polar alignment does. It's the process by which you align your telescope perfectly at that celestial pole. And if your mount tracks perfectly and there are no outside factors like, the wind's not blowing, nobody hits the telescope, you don't have an earthquake. It might sound funny, but I actually had at one time I was taking the image of the Elephant Trunk Nebula, and an earthquake happened while I was imaging it. But if everything is right, so we're just talking theory here, then your mount should be able to track an object in the night sky perfectly throughout the night. Now, that never happens, and there's another process which we'll talk about in another video called guiding that you need to have to kind of like compensate for these errors. You might have inside your worm gear just small imperfections. Depends on the mount. If you don't have like a great mount, you might have some imperfections in the mount and it doesn't track that great, and so you'll use guiding for that. But in theory, if everything is perfect and you perfectly align to the North Celestial Pole, if you're in the Northern Hemisphere, then your telescope should be able to your telescope mount should be able to just track in that one direction in right ascension throughout the night and enable you to get really long exposures. So electronically assisted polar alignment. So typically, you want to be under 30 arc seconds for really good polar alignment. And the arc second is, if you remember from the last video, is a fraction of a degree basically. To do that, you really need to get either software or some mechanism to help you with that. Now, in my case, I actually have Celestron mounts. Those Celestron mounts have a polar alignment procedure that you can do and will actually give you pretty good results. So that also depends on your focal length, but it's actually pretty good. It's called the All-Star Polar Line, and it comes with a mount. I'm not a big fan of the procedure itself because of the fact that you have to star align first. Sometimes things get thrown off afterwards, but in general, I know a lot of people who use it, and I've used it in the past. It does come with good results. So if you don't want to spend any money and you have a Celestron mount, then I would highly recommend you use that and not use the polar scope. You might want to use the polar scope just for like a rough alignment, just to get like Polaris in the right position, but really try to use that All-Star Polar Line. Now, the one that I typically use, I use something called the Pole Master. And a Pole Master is a camera that's made by a company called QHY. And I have that, it gets mounted onto the front of my mount. And basically what it does is it calculates the North Celestial Pole by tracking the position of like one star as I rotate my mount. And based on that, then it tells me or figures out where Polaris should be. And from that, it has me move Polaris into a certain position. And then you do kind of more of a fine tuning. I've been able to get, about a little bit less than 30 arc seconds. Some people online say you can't get to 30 arc seconds. I personally have been able to get to that using the Pole Master. It's a great, this process used to take me hour sometimes to get right. And with a Pole Master, I can do it in like 10 minutes. So it's a huge time saver. So I highly recommend it. It's actually one of the best pieces of equipment that I purchased. The second one that I use, and this is if I want to do like really fine adjustments, I use software called SharpCap. And SharpCap has a polar alignment procedure. I just really love it. Typically what I'll do is when I want like really super fine polar alignment, what I'll do is I will use the Pole Master first. That'll get me to about 30 arc seconds. And then I use the SharpCap tool to do the polar alignment procedure through that. And using that, then I can get really fine, typically it's like under 10 arc seconds. And it's really great because the thing I really like about it is it will tell you what your polar alignment error is as you're doing the polar alignment. So it's fantastic. The one that everybody says is the most accurate, which I'll be honest, I've never used it myself, is called Drift Align. It's in a tool called PhD, which is a free software. I've never done it. I've just been, I don't know, maybe I've just found it a little complicated when I've seen people do it online. Maybe it's not that complicated and someone will say it's not. But I typically use one of those two. So usually the Pole Master or the SharpCap. So to recap, today we talked about coordinate systems and why they're important in astrophotography. We talked about the different kinds of mounts that there are and how they track. And we talked about polar alignment and why it's super important in astrophotography. Polar alignment really is, as I said before, the number one skill that you really need to hone, because at the end of the day, it allows you to collect great data. And, when you hone your post-processing skills later, you can always go back to your old data. I do it. If you follow me on Instagram, I'm at NerdyBeardo on Instagram. You can see I actually will reprocess data from year over year just to see my improvements in skill. But you have to have good data to do that. And getting your polar alignment right allows you to take those longer exposures. It allows you to make sure you don't have star trails, because no amount of post-processing is going to fix those things for you. So if you like these videos, please click on subscribe. I'm actually going to try to follow up this video very soon with one where I actually do the polar alignment on the Pole Master and in SharpCap. so I can show you guys the procedure. So definitely hit that subscribe button, and we'll see you next time.